Okay, the recording has started, so
Yeah,
Alpa, stage is yours.
yeah. Thank you, Ben. Uh, Thank you all and welcome to my session, a case study, data movements and data transformation using Azure Data Factory here at Global Azure 2022. Uh, in this session, I'm going to provide you a very quick overview of Azure Data Factory with a mini case study where we do a data movements and data transformation using Azure Data Factory. So you can use similar idea in your data to do a data movements and data transformation. So let's start with myself. I'm Alpa Buddhabhatti and I'm working as Azure consultant at Cluster Reply. I have added my GitHub repo in this link, and you can easily find me from LinkedIn if you have any question later on then. So now let's start with today's agenda. So today's agenda is divided into two main parts. So in first part, I'm going to give you a very quick overview of Azure Data Factory. Then in second part, we're going to see our demos. We're going to see a quick tour of Azure Data Factory, and we're going to see a case study for data movements and data transformation. So let's start with first one, which is what is Azure Data Factory. It is a cloud-based data integration service that orchestrates and automates the movement and transformation of your data at a scale. And you can do it by just a drag and drop, and it supports 4 petabytes of data as well. And you can build it very, very quickly and very efficiently. It is also Azure Platform as a Service and it's a serverless. So because of these two reasons, you don't need to worry about compute infrastructure, software installation, hardware configuration, web server configuration, and many more. Azure will do it for you. So you can fully focus on implementation and you can quickly build your pipelines or workflow by using the uh, uh, focusing on purely on implementation. And because of about two reason, you only pay for what you have used. If you are not using, for example, if you are not running your Azure Data Factory pipeline, then you won't get any charge for execution. However, you get a charge a small amount of cost for a storage, which can be negligible. And last but not least, it's a low code or no code solution. So by just a drag and drop components and setting few properties, you can do your data movements, data transformation, you can apply pipeline automation, you can do pipeline orchestration. All in these things, you can do it by just a drag and drop components and setting few properties in your Azure Data Factory. And because of that, you can build your pipeline very, very quickly. So this is Azure Data Factory. Now let's move into next one, which is a key components of Azure Data Factory. So if you like to create Azure Data Factory, then you like to know the key components of Azure Data Factory. So first one is a linked services. So linked service is hold the connection strings, is authorize your data source. So your data source can be used in your Azure Data Factory by other Azure Data Factory components. So let's see next one, which is a data sets. So data sets is a structure of your data. It's a metadata of your data. It's hold the reference of your data. So for example, if your link service has a connection string for your blob storage, then your data sets hold the data in form of file. But if your link service is pointing to a REST API, then your data sets hold the data in form of the JSON file only. But if your link service is hold the connection string for Azure SQL Server or SQL Server or the Oracle database, then your data sets hold the data in form of the table. So that is a data set. Next one is activity. So activity is a particular steps in your workflow or pipeline. It do a specific task and it can be a sequential or parallel in your pipeline. And activity do a specific task. For example, copy activity, perform the copy data. Machine learning activity allow you to perform a machine learning task in your Azure Data Factory. You have Azure function activity, data bricks activity, and you have a generic and iterative activities which you have in any programming language or any database language. I will show you later on this demo. So that is the activity. Next one is a pipelines. So pipeline is a logical group of your activities who perform a specific business outcomes. It's like a workflow and that you can set automated, like you can trigger them. So you can trigger them by just debug in manually. You can trigger manually. You can set based on a various different way, which I'm going to show you later on. So these are the 5 main components. Apart from that, there is a one more components, which again I'm going to show you during the demo. So these are the main components for your Azure Data Factory. Now let's see what can you do in Azure Data Factory. So you will get idea why you need Azure Data Factory and in which scenario you can use it. So let's see a copy data. So you can copy data in Azure Data Factory in a very two different way. You can use a copy data tool or you can use a copy activity in your pipeline. So you can copy your data from various different data sources. So I'm going to show you few examples. So let's see other cloud service. For example, AWS or Google Cloud. You can copy your data from system like SQL Server, on-premise system like SQL Server, Oracle Server Database, or SFTP or FTP. You can move your data from a system like Salesforce, CRM 365, or you can have Azure Function, HTTP Web Call, or REST API, which you can call as well. So these are the simple data source I have shown you here, but you can have a many more data source. So you can have a data in any different displays, and then you apply a copy activity with your pipelines. And here you can use slightly changes. Well, you can select a particular columns. If you want to select, you can change some types and you can rename your column name or file name, and you move your data from your this source to another source or vice versa. So this is a copy data, copy activity with a copy pipelines. And in Azure Data Factory, there are around 100 data sources available, which you can use as a source or as a sink or both of them. And this is the link which help you to find out which data source you use as a source or sink or both of them. And this is called a data movements. So you can use Azure Data Factory to do a data movements very quickly, very efficiently by just a drag and drop with setting few properties. So now let's see what else you can do. So you can do a data transformation. So for that, it's use a mapping data flow behind and behind the scene, it's use a Spark cluster. So without writing a code in Scala, Python, and Java, you still can get the same features by using the mapping data flow, drag and drop components with setting few properties. So let's see examples here. So these are the simple data source I have used as a source. And then I have applied some transformation. So if you're coming from a SQL background, then you will see that you are using the select, you're using union, join, you use a window function, you use a sort method to order by order as well. And you do so many things. So those transformation you will apply after selecting your source, and then you store the result as a sink or destination. So these are the simple data source I have shown here. So for mapping data flow, it support around 18 different data sources. So this data source you can use as a source or as a sink, both of them. And this link will help you to find out that if your source is not available, then you can use a common data source. You can use a Snowflake, you can use a Blob Storage or SQL Server, and you load your data there and then apply transformation, and then you load in another data source. So this is a data transformation. So data movements and data transformation are very important part in your modern data warehouse. And even you can do like extract, load and transform, or extract, transform and load. In both technique, you can use Azure Data Factory. So apart from that, so let's go that is a data transformation which we can do in Azure Data Factory. And for data transformation, you can use Azure Data Factory if you have any scenarios to do that. So apart from this, when you create components using UI, behind the scene is generate a JSON code for you. And this JSON code is ready for your source control. So you can do a CI/CD pipelines. You can use a continuous integration and continuous deployment using that source. But you don't need to worry about this JSON code if you are not familiar, because it's generated automatically for you. It also help you to do a setup. It's a setup repository using UI, and it's has a Git integration built in using UI, and it has two kind of Git integration. You can use a Azure Devops Git, or you can use a GitHub, and it help you to monitor your components using UI. It's help you to manage your component using UI. And last but not least, it help you to trigger your pipelines in various different way. So you can trigger your pipelines by manually trigger now like that way, or you can trigger it based on a specific times, or you can trigger your pipeline based on a when file created or deleted from your blob storage. And if you're not finding any suitable triggers for your scenario, then you can use a custom activities. You can create Azure function, you can use a logic apps, you can use a PowerShell, or you can write down a code into C#. And that way you can run your pipeline by triggering your pipeline. And for that, you need a SDK. So you will get Azure Data Factory SDK, and then you can write down triggering your pipeline by programmatically way. So these are the things you do in your Azure Data Factory. So now let's move into next one, which is a quick demo. So let's go to browser, and yeah, so this is my first Azure Data Factory. So when you create a data factory, and when you go to your resource group, and when you select your particular data factory which you have created first time, it's look like this. So you can open that by just clicking in here. So this page will load. And here you can see that you do so many things. You do ingestion, you do orchestration, transformation, and even you can have your SSIS package. You can lift and shift your SSIS package as well. And you will see browsing history as well. And you will get here a few materials, which is very, very useful. You have a tutorials, you have ready-made templates, and many more. And now these are the main 3 modules. But before that, you will see that when you create a first time, and if you haven't set a Git configuration while creating your first Azure Data Factory, then it will ask you to do that from here, or it will ask from few other place, which I'm going to show you here. So first of all, let's go to see a manage tab. So manage tab help you to manage your Azure Data Factory resources. So you can create resources here, and you can manage as well. You can delete them as well here. So for example, link service. So you can create link service by just clicking a few buttons away. So for example, select your source. So these are the data source, as I said earlier, available. So let's pick the blob storage because I'm going to create a link service. So you need to give a suitable name, description, and this is the sixth important components, which is the integration runtime. So in Azure Data Factory, we have an integration runtime which provides a compute infrastructure. As I said earlier, it's a platform as a service and serverless. So you don't need to worry about a server. But however, Azure will provide it for you when it's run your pipelines or Azure Data Factory, data flow or other objects. And it has a three different kind of integration runtime. So if you have your source and sink both are on a public network, then you can use auto resolve integration runtime, which find out the default location. It will find out the automatic location which is closest to your data factory. And if your source and sinks are in maybe in on premise, then you can use a self-hosted integration runtime. And if you have a SSIS package, then you can use a SSIS integration runtime. So these are the three integration runtime. So I have a default one because my source in a public network. And here I'm going to access it by account key. And you can access using the connection string or key vaults. I'll show you later on in my another demo. So let's see connection string, and here I'm going to select my subscription. I'm going to select any random accounts, and you will see this way you can test it. So it's has now authorized my data source by link service. So now if I create this, then I can use this link service and use this blob storage data source, and I can access this file using the Azure Data Factory by dataset. And I don't need to add anything else. I just need to select this link service for that. So let's cancel that because I already have that. So you can see that everything is in JSON, and you will delete it. But before delete, you always try to find out dependency. If anyone is using your link service, this related property will show if other objects is using your link service. So before that, you will modify them and then you delete them. So this is a link service. Same way you can create your integration runtime here. It's a few buttons clicks away. You can very quickly create it. This is Azure Purview, which give you a lineage view of your data, like which columns or which field is coming from which file or which table and is going to where. It's showing all lineage view of your data. This is a Git configuration. You can configure it by using here, or you can set up it here, or you will see when you loading here, it will say set up your repository. So you can do it various different ways, three different way you can set up. So let's quickly set up it here. So here you're going to select your uh, actually let me do it later on, so you will get idea why you should have a setup repository. What's the problem if you're not setting it up? So I will show you later on. This is ARM templates. If you want to deploy your Azure Data Factory into different environment, then you can export from this uh, data factory, and then you can go to another data factory in another environment, and you can import using the ARM templates which you have already downloaded. So this is a
But maybe quick comment on those ARM templates.
yeah.
Um, I have the feeling whenever I tried that, it failed because there's a limitation to the complexity and file sizes and everything.
Uh-huh. Okay, that's a good
Um,
to know. Yeah.
yeah, so
Yeah.
this is, you need to be a bit careful because often this will not work if your data factory gets too big.
Yeah, okay, that's a good idea to know. So in that case, better to set up automated one, which is a CI/CD, like
Yes,
create your, yeah,
that's the way that works much better than export and import
yeah,
in my experience. Maybe I've just been unlucky, but the 2 or 3 times I've tried this, it's failed.
yeah. And actually, they have Microsoft has recommended to do via a CI/CD pipeline. So when I will show you when you published here, it generates the ARM templates for you in JSON format, and then you can use that ARM template for your CI/CD. So or you can use a PowerShell or different way, but yeah. Yeah, it's good to know that this may not be support for larger files. And here you can configure your ARM templates as well if you want extra parameters. So that is ARM templates. Here you can create triggers, or you can see if you already have triggers here. This is a global parameters. If you have a configuration which is a common across your pipelines in your data factory, you can create global parameters. You can have a private net. If you have a VNets and you want to create connect it in Azure Data Factory, then you need to create a manage private endpoints here. Those all things you can create by few buttons clicks away. So now let's go to next step, which is a monitor tab. It allows you, or it shows you the results. You can monitor here your pipeline run, your trigger run, your data flow run, or your integration, and even you can create alerts if you want to know that uh, if queuing time is greater than a threshold, then you like to have notification. Then you set up criteria and you will get emails if queuing time is more than a threshold. So this is a monitor one. I don't have at the moment anything. So yeah, I have a debug one. Okay. So you can see that here it's success fail, or it's run ID, and you can see more information as well, because this is a simple pipeline, but in complex pipeline you can go to inside and you will see more information here as well. So this is a monitor tab, and now this is a uh, author tab. So this is a very important module, and here you are going to create your pipelines, data set, um, uh, data flow, and there are many things like you can see that you can use data flow as well. Let's first do a pipeline creation. So you just click there. I already have it. So let's create new one. So by clicking here, it will create new one. So your activity is mandatory here if you want to save it, and you will see here who is using your pipeline as well. And let's add one dummy one random one. So this is the one. Now it allow me to save. So see, this is the importance of your publish all. So if you're not setting up a repository, every time you have to publish it, and if you not submit it, you lost your change. So let's debug this. While this one is working, we can set up repository as well. Oh, it will discard. Okay, just wait for to finish this. So this way you can see that you are debugging your pipelines. Now let's close because I don't want that. And now I'm going to set up a repository here. So you can see that it's you just selecting your repository type. You selecting your active directory. Then you click on continue. You will select here organization. You will select here projects, and then you will select your repository, and you will see that this is the main important branch. And here when you publish your code, it generate ARM templates for you, and that ARM template you can use for CI/CD, because as Ben said that there is a limitation. If your size is very big, then you can't do manually as well. So, and that is recommended by Microsoft. So by clicking here, okay, these are mandatory things. So either you create or you can select existence one. So this way you set up your Git repository, and you see that these all information like organization name, project name, repository branch, those all things you first need to create in your DevOps. For example, if you use Azure Devops, then you go to dev.azure.com. You will create your organization or accounts. Then you create a projects, you create repository, and you create initialize your repository, and then you will see them in a here while setting your repository. So now it has a set. So now you can see that you create new branch, you complete pull request, and when you pull request complete, review by your colleague and it's completed, your code goes into main branch, and then you can manually publish it, or you can use in your CI/CD pipeline few package which automatically do it for you. And once your code is deployed, it goes to here in live mode. So that is a pipeline and publish mechanism. And here you can see that you similar way how you created your link service, you create your data set as well. These all are sources. You select your source, and then you select the types, and then you will give suitable names. And here you need to select your link service which you created earlier. And you will select here pacify source container because it's really needed. And you select file if you need, and that's it. And you will see that if you have a header, first row is a header, you click this, and that's it. So this way you will create your data sets. I don't want to need this, but let's discard this. And then same way you can create your data flow as well by just right clicking in here. And here you will select your source, and that's it. See, this one also drag and drop. Selects your source, then it has a 3 fields at the moment. You can preview here, and you can add so many things like this: join, exit, union. If you want to join two different data sources, one is in CSV and one is from table, or one is maybe text, you can join two different data sources here by just adding join here and setting few properties here. Same way you can do sync. So after applying transformation, you can select, this is mandatory as well. So you can have a sync as well. So it's restore a result of your transformation into sync. And it can be cached one, or it can have a particular one, or it can have a inline one. So this is a data flow. So now let's discard this because we don't need at the moment. So this is a quick overview of Azure Data Factory tool. And now let's move into, let's close this, we don't need them. Now let's go back to our presentation. I also have added more information step by step, like how to create uh, Azure Data Factory, pipelines, data flow, data sets, and how you can use your copy activity, how you set up repository. All things I have added in this link if you like to follow the steps. So now next one is a demo, which is a case study, data movements and data transformation. So here, before we going further, I just would like to give you a problem statement. So we had a client, and client had a third party software which placing the file into a blob storage, and it's placing the file into blob storage for the n number of different business outcomes. So here client would like to do a data movements for those n number of business outcomes with n number of files as well. They can have a 1 file or 100 files as well. And they would like to apply a transformation later on based on a particular business requirements, because transformation is based on your business requirements, a particular data source based on types and whatever they have available fields or like that. And they would like to do it with a no code or no code solution, because they do not want to hire a particular expert in a field of like a other programming language or techniques. So if it's no code or low code solution, then their existing staff can learn it very quickly. And so it can they will help to do maintenance later on. And they would like to do it as soon as possible and as quickest as possible. So quick, in my mind, we got to know that it's better to have Azure Data Factory for data movements and data transformation. So for that, we have used Data Factory. And this is the scenarios. So here I'm going to show you small scenario in that business client requirements. So here we have movements. So we are moving a data from blob storage to Azure Data Lake Gen 2. And then later on, we are applying a transformation on a data lake gen to file which have for particular business outcome, and we storing the result into Azure SQL Server. So for this demo, you need these 6 resources with per environments. And here I'm going to show you data movements for n number of business outcome and data transformation for movie business outcome. Because as I said earlier, data transformation is specifically based on your source. So it's depends on your each individual outcome, business outcome. So for data movements, we have a one pipeline, and this pipeline have a blob storage, and blob storage have a container, and it has a naming standard. So here you have a movie days in. So movie is your spec code or business outcome, and it has a days in concatenation with that. Then you have a sync, and your sync has same spec code or business outcome with a concatenation of staging. So this is a source and sync for your copy activity, copy pipeline. And here we're using data moments. So for that we have a one pipeline, and pipeline have a copy activity, and it will move a file from source to sync. So if you have a one or two file, then it's okay. But if you have n number of file and you have n number of business outcome, then you need to use a metadata activity and for each loop activity with a one uh, pipeline with a copy activity. So that's what we're going to see in a demo. So let's go to here. So this is my resource group, and I have Azure Data Factory, Azure Database, Key Vaults, storage account, data lake gen 2, and this is a dummy data factory which I created for demo. So here you can see that key vaults. So these key vaults hold the secrets, and I have here secrets, these secrets. So blob storage access key stored here, data lake gen 2 connection string stored here, Azure SQL database connection string stored here. So here I have stored my secret information. So no one else know apart from who is updating these secrets. So it's secure. And another advantage is it's a central place. So if your Azure SQL data, same Azure database used for another 3 system, then you don't need to go to 3 different places and change them. But you can just change into here central place for this secret, and it will apply to all your 3 different systems. So it's a second benefit apart from security. And if you want to allow your Azure Data Factory to use this key vault, then you need to add access policy here for your Azure Data Factory for accessing a secrets. And that you can do it by just clicking here and by selecting your service principal object for your Azure Data Factory. So that is the key vaults. Now let's close this one. So, and this is a blob storage. So here you can see that I have a 4 containers, and this container naming is like business outcome days in. So I have movie days in, file days in, and this one. And here you can see that it has 3 files. And in business outcome 1, it has 2 files. So same way it can have as many files as you have in your requirements. So that is a blob storage. And I think I just moving this. Yeah, done. So here you can see that this is a data lake gen 2. And here you can see that at the moment, I don't have any container related to staging, like a movie day staging or file day staging or anything. But my Azure Data Factory pipeline runs at that time, it will create here folder based on a business outcome with a staging extension, and it move all files into that folder. So that is the one thing. And this is Azure SQL Database, but we're not using it for a pipeline one. I will show you later on. So now let's quickly run our pipeline here. Okay, before that, this is my Azure Data Factory for this demo. And I have here link service. So I have a keyword link service data source, data Azure SQL Database link service, and data lake gen 2 and a blob storage. So you can see that this is the Key Vault, which has all secrets. You can see that here, looking into this, you can't say that which database I am using, which username I am using, or anything related to secret or connection string. I only know the secrets, nothing else. So it's very secure and you don't need to worry about it also. Tomorrow, if you want to point this link service with another database, you just change your secrets and your link service will change a point to that database. And you can test it by here. And so it's now authorized it. So now it can be used by a dataset in my Azure Data Factory. Same way I have done for a blob storage and data lake gen 2. Secrets come from the key vaults. And let's cancel this. So that is my secrets, link service I have used in my Azure Data Factory. Here you can see that this is my pipeline. And let's go to this one. So this is the pipeline which move data, which load data from n number of business outcome to a particular business outcome in a blob store in data lake gen 2. And you can see that I have used a metadata activity, and here you can see that it's pointing to blob storage and it's looking for particular business outcome, not everything. And here you can see that I'm using concatenation for a pass spec code or business outcome des in. So this is my container in blob storage. I'm looking for all files in that container. You can preview as well here. If you type here your business spec code name, because that is a parameter. So you will preview as well here. You can see that this is the 9 records, which is a combination of 3 files, because I have 3 CSV files there. So that is the one. And so this will send a result of 3 files into for each loop. And in my for each loop, you can see that you just interested child items. So all file names, and it iterate one by one. And here I have a copy activity, which has a source and sink, but I have parameterized it. So you can see that this 8 items dot name, which is a current file in your for each loop, current item in your for each loop. And this is my spec code, and this is a sink. So it's moving also in a same spec code, but this staging, because here is concatenating it with a staging. And this is a function in here. You have so many functions here if you want to add concatenating your sync file with a timestamp or something else. Or you can do so many other things like logical functions and like that. So that is the data set. And now let's run this pipeline very quickly. So I'm running it for a movie. Okay. So while it's running, you will see that here I don't have a movie desk staging container in my data lake gen 2. This is my data lake gen 2. But however, I have same in here because this is my source and this is a blob storage. So here I have 3 files. So my for each loop run for 3 times. It try to create a container in a data lake gen 2 if it's not available, which is a movie desk staging, and it's move all 3 file into there in here. So let's go to see here. So it's you can see that metadata activity ran and it has 3 child item, and it's passing this 3 item into my for each loop. So for each loop run for 3 times, and it will copy a one by one file in a data lake gen 2. And here you can see that this is icon which show you which file, like from where to where. So this is a blob storage to a data lake gen 2, and you will see the other information like data read, data file read, data written, or many things. Or you can see here like queuing time or transformation time as well. So that way you monitor here as well. So it copied 3 files and is completed. So if now I come to here and if I refresh, you will see a new container which is my spec code, which is a movie dash staging, and it has 3 files as well. So let's go back to here again. So at the moment now I have 2 container. So if I run one more time this, but this time I'm going to give you give here business outcome 001. So it's running it, and you will see that in here in your blob storage, your business outcome 001, you have 2 files. You can have 100 files as well. So it move 100 files into my data lake gen 2 here. It will create a new container which is BO001 dash staging. If it's not available here, then it move all files from that blob storage for that particular container to here. So let's see here. So you can see that it has now 2 files in this container, which is business BO001 days in container. And so my for each loop work for 2 times. And here you can see that it done copy for 2 times as well, and it's done successfully. And if I go to here and if I refresh here, you will see a new container if it's not available already with the extra files if it's already there, or it create a container with the new files or current files. So here you can see that now it has a BO001, this one, this staging, and you will see that they have 2 files as well. So this way it works for your n number of business outcome, and it do pacifically move your file from that particular container to a particular container related to your business outcome. And so that is a demo for data movements, and this can work for n number of business outcomes, and it can move n number of files as well, and it do it very very quickly. This I have built in 30 minutes maximum. So that way you can see that how quickly it is to build your pipeline using Azure Data Factory by just drag and drop components. And now let's see back here. We're going to see a data transformation. So this is the second pipeline. And in this pipeline, now we are getting a data from my loading zone, which is a data lake gen 2. And then my sink is Azure SQL Server. You can have anything else as well, but I have used this one. And my data will move from my moving staging, which is a data lake gen 2, which is a result of the pipeline 1. And here I'm going to apply some transformation because I don't want to load all data in my Azure SQL Server. I only and only want to load the data which is useful from my business outcome. So that's why I need a filter here. So I'm applying filters, I'm selecting particular columns. In fact, I am uh, splitting one column into 3 different columns, and then I'm applying aggregation, and I'm using the filtered result into my Azure SQL Server. So for my movie data set, I would like to know the movie which is released in a particular year, which is a comedy movie, and which has a higher rating, which has average rating is good, or I just want to know average rating. So those information only and only I'm storing into my Azure SQL database, not all other things. So it will give me the idea which movie is rated nice, good, and it's released on a particular year, and it's a comedy movie. So those answer I can get it based on this outcome. So now let's go back to here. So that this is my data moments, and this is my data transformation. So let's run this one. So I'm reading it from movie, and I'm applying this file names here. So while I'm doing this, I just want to show you transformation, what it is doing. So this one is reading the file from data lake gen from staging area. Here you can see that I'm interested all files because I'm saying start.csv. So all CSV file from that movie spec code or business outcome. And then here I'm applying the filters that I am interested on particular years. You can add more information as well here. If you click here, you will see more information. So this is a powerful expression, and behind the scene is used Scala. So you can see that it has a lot in numerous of functions. So these all are function you can use it here. You can select a particular field from your source. You can have a parameters as well. You can have a lookup as well, and you can have a this data flow library function which is in preview at the moment. And this you can just do by just selecting here like this way, and you pass here your number, whatever you want to pass, parameters or like that, values or, and you can let's cancel this because I had did more extra things as well. And you can see a result as well here. If you have a data flow is available or running, then you can see here refreshing as well. So that is the one thing. So now I'm adding a new derived column. I'm just giving random name and I'm giving expression calculation here. Similar way you go to here and you will see that. So what I'm doing here, I'm trying to find out if my address has a new line or it has a carriage written or it has a comma, then you just need to replace by comma. So that I can use it in my next transformation where I'm just splitting my data based on comma. Because at the moment it's not only comma, it can have a comma, it has a new line or like few other things as well. And then here actually I'm splitting my data in 4 different formats. So I use the split function here as well. So you can see that this is a split function, and this is my input which I got it from this schema, and I'm splitting them by comma, and then I'm using first value which is a house number. Here I'm using second value which is house name, city name, and whatever it has fourth one. So that way you can split your one column into 4 different columns. And here I'm going to do aggregation. So I'm doing window function and I'm doing group by year and I'm giving the average ratings here. And then I'm storing those results on a SQL database, not everything else. And I'm also storing the extra information in my data lake gen too with these splitted columns as well. Okay, so that is the things. What else I want to show you? Preview. So here we can do preview as well. For that we need to set a few parameters. So like
Alpa,
movie. Yeah.
you have about 10 minutes left,
Yeah.
just
Okay.
as a warning.
Yeah. Okay. Thank you. So here you can give a table name movie DB. You can give a schema and you can give spec code here as well. So we have a movie spec code and yeah, okay, that's it. So here now you can preview your data before commit anything on the fly while you creating your data flow. And it help you to see a debug as well. If you want to debug something or you want to make sure what it doing, then you first apply that a preview. So you can see that now I have a 9 rows in here, and this data came from 3 different files from my data lake gen 2 for movie business outcome. You can export this result and you can apply few filters as well. If you have a huge amount of data here, then you can download it and then you apply filter there as well to verify something. This is a filter results, and you even can do it here before you loading into database. You can preview here as well, but just wait here because oh yeah, so filter results now giving only one results. no, sorry, 8 results. We had a total 9, but now it's filter and it has 8 results. And I directly doing this here. So this is the data. I can preview it that after applying and filtering my data, how much left, like you can check it here, like how much data you have now. So now I have only and only 3 rows, and I have only 2 columns. But here, if you see, you have a 13 columns and you have a 8 rows. So this information goes to my SQL database, and 13 columns with all information goes to data lake gen 2 in a movie container. So as we have ran this one, it's successfully done. So now we will see here, let's remove this because we don't want to run this. You refresh here, you will see that it created a table, and you can select here and you will see it has a 3 outputs with 2 rows or 2 columns. And if I go to my data lake gen 2, and you can see that this container, and you will see that this file has just created here, and you will see a result as well. So here now it has 8 rows with these data, these extra columns, because I have used split columns. So that is the things. And let's go to what else I would like to show you. So yeah, so this is a mapping data flow, and you can see that I am passing 2 parameters, which is spec code and file. Here you can see that uh, which data flow you're using actually, and you passing parameters here as well. And that's it, I think. Let's go back to presentation. So we have seen this transformation for movie business outcome only, but you can create for similar for other business outcome as well. You can reuse your data flow by just changing few more things as well. And now here you can see that how it will look. So like we are storing initially we have data in blob storage, we use data movement pipelines, our data moves into data lake gen 2, and then our transformation pipeline will pick up the data from data lake gen 2, is apply transformation and store the result into Azure SQL database. So with that, I would like to conclude this session. So we have seen that Azure Data Factory is a cloud-based data integration service which help us to do data movements, data transformation, pipeline or workflow automation, orchestration. You can easily build your data integration solution using Azure Data Factory, and it's a serverless or a Azure platform as a service. So these are the things. Then we have seen a key components of Azure Data Factory. So we have around 6 key components of Azure Data Factory. So first we had a link service, which is nothing but a connection string holder and authorize your data source. Then we have a data sets, which is a metadata about of your data. Then we had activities, which is a specific task or steps in your pipeline. Then we had a pipeline, which is a logical group of your activities. And then we had an integration runtime. As you know that Azure Data Factory is a serverless and platform as a service. So integration runtime provide your compute infrastructure. So these are the 6 components. Then we have seen a quick tour of Azure Data Factory. So here we have created a pipeline, data set, data flow. We have created a link service. We have debug our pipeline. We have trigger. I don't think we have triggered yet, but we can trigger our pipelines there. And we had set up repository as well. So these are the things we have seen there. And then last but not least, we have a demo with ELT or ETL and mini case study. So if here we have moved our data from a blob storage to Azure Data Lake Gen 2, and then we have another pipeline which pick a data from Data Lake Gen 2 and apply some transformation and store a result into data Azure SQL Server. So these are the things we have seen in our last demo. So with that, I would like to thank you for attending this session. And I also would like to thank you for organizer teams, volunteer teams, and speakers and listeners. Thank you, Ben.
Yeah, great presentation, Alpa. Thank you very much.
Thank you.
Always lots of content when you present. Maybe a quick question regarding usage and costs of Data Factory.
Uh-huh.
Because I found that when you use the data pipelines, if you're not using simple copy activities, the data pipelines are quite expensive as you process more data.
Mm-hmm.
Is that something you've experienced as well?
No, we haven't experienced that because in our my company we are using the data flow as well. And earlier it a little bit hard because it take time to spin up the cluster as well. But I think it's improve a lot now. Okay, it
Yeah.
doing very quickly as well. And yeah, but it's up to us like how much we loading. If we loading everything in copy activity, then it's okay. But when we apply a data mapping data flow, then we can use maybe new features which can reuse a data flow as well. So maybe it saves some cost as well.
Yeah.
Yeah.
Okay.
Yeah.
If there's no other questions from the audience, then thank you very much again.
Yeah. Thank you, Ben. Thanks.
It's been a great presentation and good to see you as always.
Yeah, same here. Thanks. Bye.